Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series, Efficiency and Sustainability in Future Transportation. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Schneider Electric. Schneider's purpose is to empower all to make the most of their energy and resources, bridging progress and sustainability for all. Their mission is to be a digital partner for sustainability and efficiency and drive digital transformation by integrating world-leading process and energy technologies, endpoint to cloud connecting products, controls, softwares, and services across the entire life cycle, enabling integrated company management for homes, buildings, data centres, infrastructure, and industries. Schneider Electric are advocates of open standards and partnership ecosystems that are passionate about our shared, meaningful purpose, inclusive, and empowered values. Now, today, we'll hear from two speakers, followed by our live audience Q&A. We'll also have three new panelists join us for the Q&A. Now, I encourage you to please send your questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Pauline Blois-Georges, Global Commercial Leader for the Transportation segment at Schneider Electric. With over a decade of dedicated services at Schneider Electric, Pauline has amassed a wealth of experience and expertise within the power services sector. Having held pivotal roles in marketing, national strategic account sales, and category offer management across Europe, Pauline has demonstrated remarkable versatility and leadership. Their journey led them to Canada, where they spent 3 impactful years leading both inside and outside sales teams for secure power services, gaining invaluable international experience. Now, Pauline has embraced an exciting new challenge as the Global Commercial Leader for the Transportation segment. Driven by a passion for innovation, they are committed to leveraging their extensive background to spearhead transformative strategies and initiatives for the transportation of the future. Please join me in welcoming Pauline Blois-Georges.
Okay, thanks for introduction, Megan. Good afternoon, everyone. I am happy to be here and to represent Schneider Electric to speak about the transportation of the future. We have really a key challenge on our infrastructure of the future, and I would like to deep with you and my colleague Juan Martin about some key points for the infrastructure of tomorrow. So why transportation infrastructure is going through a massive challenge. So transportation is facing an enormous challenge in the current scenario. And in Schneider Electric, we take care about it and we consider this huge transformation very important. So why this massive challenge? As I said, one of the most pressing issue is the rapidly increasing demand for transportation, which is expected to rise by 3.5 times by 2050. This rise in demand can be attributed to factors such as population growth, urbanization, and changing customer behavior. Another significant challenge is the high level of green gas emission the transport industry produces. It has been reported transportation is responsible for a massive 24% of global greenhouse gas emission. So it's huge. This leads to environmental problems such as air pollution and climate change and has a significant economic impact. So third pillar, it's great. Governments start to work on it and start to recognize the importance of investing in transportation infrastructure to address this challenge. Such incentive can go a long way in accelerating this shift toward sustainability transformation system and mitigating the challenge we have. So we can have some example, for example, Europe Next Generation. We have 750 billion euro. We have an investment also of US bipartisan infrastructure deal for $150 billion in transport infrastructure. So step by step, everyone is recognizing transportation infrastructure of the future is very key. Transportation infrastructure of the future will be integrated, decarbonized, and climate resilient. We have a big challenge. In Schneider Electric, we consider this transportation segment very key. For us, infrastructure of the future to connect the people to place sustainably. So what is the transportation segment in Schneider Electric? I wanted to give you just an overview about our definition. Transportation segment for us, it's different subsegments. We consider airport, railways, and urban transportation. It will be our focus for today, port and road. Our customer challenge are rarely linked to the trend. The trend are sustainability, population growth, urbanization, as I mentioned, intermodality, and growing passenger and freight transport demand. So the customer challenge are electrification, digitization, and decarbonization. So we will deep a little bit about this customer challenge because we consider this customer challenge our value proposition in Schneider Electric. Our transportation segment in Schneider, it's worldwide. We cover all the world, every country, every zone. And we are in a diffuse segment. So it's a particular segment, but we have also big global player worldwide. So I would like to highlight how Schneider is considering the transportation of the future, the infrastructure of the. And here we have 3 ways transport operator can build the infrastructure of the future through the end-to-end solution across the life cycle. The first one, it's digitize. The first way is by digitizing and improving efficiency at the facility level. We learned that this is all about creating smarter facilities that utilize the technology to enhance their performance. By doing so, not only do we create more productive and efficient working environment, but we also reduce the operational cost and increase overall efficiency. The second way is to decarbonize. Decarbonize, this entails the reducing environmental footprint by implementing measures such as electrifying, reducing and replacing and engaging also the value chain. In fact, additionally, it's important to engage in the value chain to ensure everyone is on the same page. Everyone involved is on the same page in terms of the sustainability and in terms of the environmental impact. The third way, it's finally electrify. Implementing power outage is key and ensuring the continuity of services. Our customer in transportation, because at the end we are speaking about passenger, need to have a continuity of services with reliable electrification. Electrification is the basics. This means implementing measures such as backup power sources, smart grid, and renewable energy sources to ensure we are always power up and operational. With reliable electrification, we can safeguard against potential business disruption and ensure business continuity is maintained regardless of external factors. So now I would like to go on the urban transportation. In Schneider Electric, as I mentioned, our subsegment, we consider railway and urban transportation is key. Why urban transportation is essential for the city? Urban travel demand has been continuously growing in both developed and developing countries. Some example, plus 24% urbanization rate, plus 34% of population growth between 2017 and 2050. No of the cities with population between 1 and 5 million to increase from 467 in 2018 to 597 in 2030. Plus 100% global rail passenger demand. We have a huge challenge in front of us. A huge transformation is coming, and it's already starting. A city with more than 1 million inhabitants will ask a metro, a tramway system, sooner or later. It's a big misalignment between the number of these kind of cities, close to 500, and the number of metro network worldwide, around 200. You can imagine the transformation we have in front of us. So in Schneider, we consider different implications. We consider different part, I would say. So metro, light rail, tramway, buses. Implications, so, will be increase the number of metro line and station in the world. Emergence of new mobility models also, and multimodal, tram, metro, bus. We will have a dedicated focus with my colleague Juan Manuel for buses. Need for passenger flow management. We have more and more need about the passenger flow management. Better security and safety measure. At the end, we are speaking about passenger. Constraints on existing infrastructure and car sharing services. It's another example. So in Schneider Electric, we consider this urban transportation very key, and the urban transportation, the urban transport infrastructure must transform to make the cities greener. How we can do it? 4 value and 4 key pillars. 4 main pillars, I will say, that support our strategy on railway. First, it's reliability. Nobody would like to have the experience of London, or again, New York. London, 2-hour downtown, metro, impacted 250,000 commuters in 2017. More recently, 2019 in New York, metro impacted 73,000 passengers due to the 5 hours downtown in New York. You can imagine the trouble. So reliability is one of our key pillars. Electrical energy is the basic resource for a rail system. It's used to power the main consumer in the system, the rolling stock, and the rest of the other consumers present along the line, such as signaling system, telecommunication device, point heater, and other critical elements. The unavailability of these critical resources is going to impact in the operation. No electrical energy, no services. So it's very key. Only a reliable electrical network is compatible with the level of services that is requested in modern rail system. Second pillar, safety and comfort. Safety and comfort, we are speaking again, I insist, we are speaking about passenger. Passengers are the most reliable assets, so any effort to take care of them is well used. Safety of people in the different situation that arise when they use a rail system, such as a tunnel, must be a priority by any rail company. 5.5 million of people traveling every day by New York Metro. You can imagine the number of passengers. If it's something happen, the trouble, as I mentioned just earlier, could be very enormous and huge and have an impact, a very negative impact. So safety and comfort in both surface and underground station and tunnel is very key. Service cannot be considered completely without a good traveling experience, and comfort is a very relevant variable to consider in this field. Third pillar is digitization. Maintenance costs could be reduced by up of 10% to 20%, and availability improved by 10% to 20%. Operational efficiency is one of the obsessions in modern railways. We need to do more with less use of resources, or more with the same amount. To increase the efficiency in the process, digitalization is a very strong ally. Digitization is implemented in the way we operate the facilities, with a clear process of centralization and maintenance, adapting the process to the current state of the asset and not trusting in general rules. Four pillar, last pillar, and not at least, green mobility. We will have a focus, as I mentioned with my colleague just after, green mobility, it's sustainability. I will speak also just after about sustainability. But green mobility, on this pillar 4, its sustainability is a key topic for most municipalities around the world. We can contribute to the objective in several ways with a progressive electrification of the mobility system. Europe plans 100% of the electrical bus by 2030. Another important key information, in 2018, renewable accounted for 30% of electricity powering Europe rail. So we have more and more, I would say, challenge, but also solution to address this green mobility. And in Schneider Electric, we adapt and we develop some dedicated application to these 4 pillars. So I would like to show you in Schneider how this value proposition can provide several solutions for this 4 areas to digitize, automate, and decarbonize the urban transport of the future. Electrify, digitize, decarbonize, it's really the message and our solution to build the urban transport of the future. So, reliability. We can provide solution to manage the traction and non-traction network and other relevant facility in railway system, such as a passenger station and tunnel, including in both cases, electrical infrastructure in medium voltage, low voltage, and the supervision also and the management software, with the management software. We can highlight the advanced automatic restoration automatism and the implementation of digital twin concept for the more relevant assets. Safety and comfort. As I mentioned, ensure the safety and comfort is both outside of underground station and tunnel. So we can provide some solution, including the control system for tunnel and passenger station, where safety and comfort is a relevant topic, and where the management of emergency and operational scenario is the base of the facility's operation. Digitization. Digitization is a point where in Schneider, we consider the responsibility of the normal operation is delegated to the entity called control center. We have a solution to have a unified control center. From this facility, we can control and supervise the maintenance of all the main rail facilities, power station, power substation, passenger station. We are able to do a predictive maintenance. We are not waiting the corrective. We are not waiting any troubleshooting. We are working on the predictive maintenance thanks to this digitization. It's very common to consider these facilities an independent silos. We must break this conception to shift to a new paradigm of a cyber-safe unified operation center. Cybersecurity is key. When we speak about digitalization in Schneider, cybersecurity will be on our product, our software, and our application. Okay, last pillar. Last pillar, as we mentioned, is decarbonization. In Schneider, we can provide, in terms of the sustainability, solution for the electrification of bus depot, including the electrical distribution and supervision of the facility and process inside the depot. I will not deep now, because again, my colleague will address this topic. In the case of passenger station and again bus depot, we can manage the installation of microgrid to enrich the energy mix used for the powering of the facilities. Okay, so I would like now to share with you the ecostructure for urban transportation. So, as I mentioned, urban transportation in Schneider Electric, we consider 4 key pillars to address the infrastructure of the future for urban transportation in different parts. In Schneider Electric, we have a strategy. We are on the technologic foundation approach. We have a strategy of acquisition of software company. So to address these 4 pillars, reliability, safety and comfort, digitization, green mobility, we use our 3 layers. So we are manufacturer, you know that. We have the first layer with our product. Then we are able now to connect on-premise our equipment with the edge control. So to give the visibility to our customer to see what's happened on site. And thanks to our strategy of acquisition of software company, we acquire company to design, to build the electrical domain, to reinforce the software solutions such as AVEVA or ETAP. And we have tools to maintain. We are able to have the third layer. So the last layer on the top to connect and to have an organic development to propose a portfolio of software for digitalization. So we can address this reliability, the safety and comfort, and the digitization and green mobility thanks to this 3 layer with the on-premise and the connection on the cloud to give you and to provide to our customer the predictive analytics thanks to our expert and this different software with agnostic view. Independently on the brand, we are able to connect with the system already installed by our customer. And it's key because we have a lot of extension also. We are speaking about new way. We have new metro in the future. We will have new metro and we are starting to work. We start to work on new metro. We have started already, but we have also some extension. We have extension also of station. We have extension of metro line. And we need to take care about what is installed in the Schneider, in customer system in terms of the software. So this agnostic approach, this technologic foundation approach, allow us to connect with and to adapt the new solution to the customer install base asset already in place. Then, as you can see on the right, we have the field services. What we consider field services. So in Schneider Electric, we are manufacturer. As I mentioned, we are more and more on a strategy of acquisition and software. So we are a company to provide solution, software, and we also take care about the life cycle of our asset. So consider Schneider Electric Services. It's the lifelong partner of our customer. So why we have 6,500, more of 6,500 experts worldwide, more of 230 consultants within 430 service centers in different of 140 countries. What we consider Schneider Electric Services, it's really the life cycle of equipment. We are able to provide consultant, sustainability consulting, digital transformation consulting, work with you to define the strategy, to have the consulting and design approach for our customer, for our end user. And we are also we are able to taking care thanks to our field services representative of our equipment, of our assets. So we call it EcoCare, thanks to a recurring contract, maintenance contract. With the digitalization, we are able to have some predictive. We are able to have a 24 hours, for example. And the end of the life cycle of the equipment, of the asset, to allow the life extension with the spare part, to allow the replacement and the new life of equipment, speaking about circularity. Jumping on circularity, I jump on sustainability. And I would like to go on this last, but not at least important point for me, the sustainability today. In Schneider Electric, sustainability story or unique value proposition is to support our customer on climate, from strategy setting to execution. And it's key. It's not only the strategy, we are going to the execution too. So we define our sustainability part with three key pillars: strategize, digitize, and decarbonize. So if we go and decarbonize, we need to take action on decarbonization strategies through practical decarbonization level. So you know for sure this refer of the scope. We refer to the scope 1, the scope 2, and the scope 3 emission with different category of greenhouse gas emission. So very quickly, scope 1, it's a direct emission from sources. They are owned and controlled by the organization. Scope 2, it's indirect emission from the consumption of purchased electricity, heat, or stream. Scope 3, there are all other indirect emission that occur in a company's value chain. In Schneider Electric, we can provide solution, electrify, as I mentioned. In operation, we are able to provide some solutions thanks to the microgrid. Scope 1, 2, reduce energy use. We can work on it thanks to the digitization, the efficiency, optimization. We can reduce this scope. Replace energy source. So we can use other energy source. And engage. Engage, it's the more difficult, I would say, point to address with our customer. It's the last in scope 3 level because it's very complicated to track. And when it's complicated to track and to measure, it's not easy to find the good solution to address and to improve. So in Schneider, we have some solution to support thanks to the circularity, as I mentioned just before, for services. And we are able to support on end user on this engage to work on the value chain, the global value chain of our customer. So how we translate it for this decarbonization, accelerate the decarbonization journey in Schneider is through our digital transformation using EcoStruxure. So EcoStruxure, it's the naming on the offer, but what is key and important to highlight here, it's these 4 point: electrify, reduce, replace, engage, referring to the scope 1, 2, and 3. Thanks to our 3 layers I presented to you just before, we are able to address each scope and to support our customer to step by step reduce the gas emission to address the decarbonization with different solutions. So I will stop here. I would like to say thank you for your participation. Don't hesitate to ask any question. We can have also another next step exchange in the future. Now I will leave the floor to my colleague. He will deep on the urban transport needs, fast charging infrastructure. We mentioned the buses and other modality. So I let you discover. Thank you so much for your attention.
Thank you, Pauline, for your presentation. I'd now like to welcome our second speaker, Juan Manuel Martin, Solutions Architect at Schneider Electric. Juan Manuel holds the position of Solutions Architect with global responsibilities for the areas of railways, urban transportation, and road tunnels at Schneider Electric. His scopes of responsibilities in defining architectures, including electrical and supervision equipment, control center infrastructure, as well as advanced maintenance services and data analytics. With over 25 years of extensive experience, he has fulfilled various roles encompassing technical, commercial, and managerial functions within the railway sector. Based in Madrid, Spain, he participated in different electrification projects during the development of the high-speed rail networks in the country. Currently, he collaborates with a university in Spain in teaching their postgraduate master's program in railway systems. His significant role in advanced architectures for the railway sector has provided him with a deep understanding of the railway solutions that Schneider Electric is capable of delivering to the market. Please join me in welcoming Juan Manuel Martin.
Okay, Megan, thank you very much for the introduction, and I will continue the journey in the efficiency and sustainability in transportation that has been started by my colleague before me. As we have seen in the previous presentation, our roadmap for decarbonization as part of the sustainability strategy in Schneider includes the following topics. Electrification of operations. So you have to use electrification as much as possible in your operation, replacing any other potential source of energy that is not going to fulfill the objective of the decarbonization. Reduction of energy use, but increasing efficiency is not only replacing the energy, is to use the energy in a more efficient way for your own processes. The replacement of energy sources, but green ones. Not all energies that are available are suitable for this use case. So you need to use what you are considered the green ones. And finally, to engage the full value chain. the partners that you have in your company and in your processes are also have to participate also in the process of decarbonization. Let's go to see some concrete examples of this decarbonization process using especially electrification of operations. We are going to consider a couple of examples. First one is going to be the fast charging infrastructure. It's a good example, as I say, of electrification of operations. And the second one is in a broader technology because it's used in the fast charging infrastructure. We will discuss about microgrid solutions. With these two topics, I think we will have a very good overview of what are experiences of Schneider into the electrification of operations. Yes, when you try to solve a problem, it is interesting to detect the relevant parameters that are affecting to this problem and to try to make a segmentation using the criteria that you have selected. In this way, you will have a better understanding of the problem, and it's a way to not to spend efforts in something that is not going to produce a clear return. CO2 emissions is one of the key parameters that you can use for better understanding the energy landscape. When you do that, you make not only a very nice discovery that 25% of the total emissions comes from mobility. This is incredible, but this is the real fact. And this is the second most CO2 emitting sectors after only after power generation. If you take this 25%, inside this 25%, the 70% is related to road transportation. I mean, urban buses, municipal trucks, school buses, everything that is related mobility inside the municipality. So roads and all the topics we have seen are a niche where electrification must focus. And there are very good opportunities of improvements in the area. The other areas, aviation, shipping, are going to provide less output regarding decarbonization. So the focus has to be in the road area. First of all, let's focus on electrification. There is a clear worldwide commitment on the topic, and the ambition is that 50% of the global energy mix will be based on electricity by 2050. Currently, the situation is not so good. It's only the 20%, and we have a long path to cover to reach this 50%. Topics that has to be considered and we have to face in this electrification process are the following. First one is the energy efficiency. I said that it's not only to replace the type of energy that you are using, it's also to use less energy in the process. Don't forget what is the final objective, that is decarbonization. Energy that is, not all energy is suitable for that. So only energy that is going to produce this decarbonization process. And finally, resiliency and safety. Electricity is going to become a critical asset. So we don't have to create a new problem. We don't have to create a new problem and new challenges with this replacement. Well, electrification is affecting not only transportation. It's a global tendency affecting the energy landscape that is moving from a centralized paradigm to a distributed one. Moving from a situation with a limited number and very predictable central source of power using some kind of fuel to a new situation where we have a large number of distributed generators with uncertainty in the production capability. The main objective of green mobility is the decarbonization of public mobility in order to get a more clear environment. The awareness of climate change challenges are forcing a transition to sustainable transportation alternatives that need to be powered in some way. But there is a side effect, probably not considered initially. These sustainable transportation alternatives can also play an interesting role in the new landscape. They can be an energy consumer and a potential power source to meet energy demand, both at the same time. We have an element that can be considered as a load that needs power to work, and a way to store energy that can be shared with the grid if needed. This duality must be managed to optimize from technical and economical point of view, and it is affecting the behavior of the system. This is the context where fast charging technologies develop to electrify urban mobility, to provide energy to electric vehicles, but supporting the new energy landscape. Let's focus on urban mobility as a concrete use case. There are several ways to achieve this electrification of transportation system, depending on the energy vector that is used to store the energy. But today I'm going to focus on the combination of two different elements: a battery to store the energy and a charge unit to provide the energy. As much as possible, energy has to be loaded in the battery according to the limitation of capacity, and has to be done as fast as possible to reduce the charging time. Remember that during the charging time, probably operation is difficult or even is cancelled, so this is a very critical parameter. And also people normally, according to the previous ways of transportation system, is expecting a very short timing in terms of the charging time. These are the elements that define the concept of a fast charging solution: a high-power charging infrastructure that charges a battery in a quick and very efficient way. Several use cases for a solution like this can be used in electric vehicle cars in transit inside the city. This is probably the typical use case that we have seen and we see all around us. It can be used also by buses and trucks in parking depots or even in transit. Sometimes it is not possible to charge the bus in a depot, and then you need to charge in the stops because, for instance, in a 24 hours operational bus. There are also several services based in the use of fleets of vehicles that are moving around in the city, for instance, for cleaning, for posts, there are all the other cases. And finally, even in ports, in airports, even being industrial facilities, but has a special relationship with the cities. There are different internal services that are using also this power inside these facilities. There are specificities in the different use cases that are affecting, for instance, the capability to predict the need of energy. It's not the same case, the buses in where they have a clear scheduling that is going to make a favorable conditions in order to make the estimation of what is the energy that is going to be used in the next journey, compared to the case of the private car that it is a little bit more unpredictable and difficult to use this information in order to optimize the process. The fact is this fact then is going to condition the optimization process that has to be implemented depending on the different use cases. Once we have defined the high-level requirements of the solution and the main use cases, let's go to the details. Now you can see how a fast charging station is. We have here two different views. First view on the left is the pure electrical one. We can see here what is called a single line diagram, and we can see the main elements that are in a solution like this. So we can see, for instance, the connection to the grid, which is the one who is going to provide the energy, the medium voltage switchgears, and also the medium voltage transformers in order to adapt the energy to the needs for the charging process. And we have also the distribution system that is going to distribute the energy from the grid connection to the different chargers. On the right, you can see the physical elements. What is the appearance of the elements that are going to implement this single line diagram? This is what we call the lower level of the three levels of the solution that we normally provide. It's the connection to the real world. It is called the connected product level. We have another set of solutions that are implemented mainly at customer premises, what we call the edge control, and partially at grid level, that are really the core of the solution. What is the digital layer? Digital is critical for this use case. This is a very, very interesting and critical layer with a lot of value that is created. I will mention four areas that are critical for that. The first one is the load management, that is managing the charging process. So at the end is the optimization, how to split the energy between the different chargers. Not all the chargers need the energy at the same time. This is a bad strategy. So you can consider the other information that is available in the systems in order to optimize this process. So for instance, in the case of buses, if you know what are going to be the need of energy of the different buses, you can optimize this process. If you know when the buses are going to leave the depot, you can optimize the process again. So at the end, the objective is to do the charging process as intelligent as possible according to the requirements, the service requirements. This one is operation management. In operation management, you have to implement the operational plan of the facility, and it's normally focused in power management. So I mean supervision, operation, so probably quality of energy. There are other aspects that are implemented in the operational plan that are implemented by this level. Third one is microgrid and energy management. In this case, the problem is different. So you don't have to manage the split of energy in the depot in the different charges, but you have to manage what type of energy are you going to use. What is the source of your energy? You have different possibilities. We will see later a little bit more regarding this topic. And finally, we have asset management. So don't forget that we are talking about equipment that has to be maintained in some way. So this subsystem is, the focus of this subsystem is the maintenance. Maintenance normally implemented using condition-based and predictive maintenance. You have information regarding the assets because you are monitoring the assets. So you have a lot of info that can be used in order to estimate what is the current status of the asset and how to use this information in order to make the predictions of what are the potential issues that the asset can happen in the future regarding the topic. These four pillars, along with the sustainability management that is not included in this slide, concentrate most of the value that is created by the digital solution. In order to perform a correct implementation of a fast charging infrastructure, is much more than supply a list of physical components, as we have seen in the previous slide. You must also cover the full life cycle of the facility from design to operation. So first of all, regarding design, you need to participate in this phase in the early decisions that are taken, such as, for instance, the energy strategy, what are going to be your source of energies, and the preliminary design of the solution to cover the requested service and to provide a future-proof infrastructure. You need to participate also during the build phase, helping during commissioning and providing enough flexibility to build scalable solutions. The solution are going not to be static, it's going to evolve. So that is the reason why the build phase is also very important in order to be sure that you are able to evolve the solution in the future. And finally, you have to participate also during operation and maintenance phase in order to maximize the reliability, the efficiency, the safety, the sustainability, and of course, the profitability of the installation that will be defined by the CapEx investment. These elements are extremely important, and they are also considered by infrastructure owners as well as how good the technical solution is fulfilling the requirements. Both things are very, very important. When you must make a change in something, it's difficult to do it in one single shot. It's easier to do it progressively, using small steps. The implementation of all the subsystems that we have seen in the previous slide around fast charging units will be challenging. So we use the same strategy and the same plan when we propose to our customers to make the evolution. It's a challenge. We have prepared a 4 stages plan to migrate the current non-electrical infrastructure to the new paradigm. The first stage is focused on the asset monitoring of the charging infrastructure, performed locally and cloud-based. Second stage adds a new element, operation management, control and monitoring of the assets, and improving the asset management with condition-based capabilities. As you mentioned, we have more information in order to improve these two areas. In stage 3, we introduce load management to optimize the charging process according to the energy needs of the service. Remember that this is to use the information that you have regarding the customs and what are going to be the use of the energy in the vehicle in the next day or in the next period of time in order to optimize the charging process. And finally, in step 4, we have included the microgrid solution to optimize in this case, the energy mix that is used in the charging process. There are several possibilities to power the system, so you have to choose what is the most optimum one in each moment of the time. So this is, let's say, the plan. Perhaps we have a customer that is mature enough in order to jump directly to the stage 4, as we will see in the success history, in which we will see one case of this type. And then we will have other customers that will stay always in stage 1 because it's enough for their needs. This is something that can happen, but the model supports all the heterogeneity of customers that are normally in the market. Let's focus now very briefly in the concept of microgrid. We have used in the fast charging infrastructure, but it is usable in a broader range of critical facilities, such as, for instance, in airports, in hospitals, in data centers, which is very critical, and also universities and other entities. Microgrid is an electrical distribution network, including distributed energy resources for generation, storage of energy, and flexible loads. These three elements are the key pillars of the microgrid. The system is able to work in three different operational scenarios. First one is the always connected, when it is expected that the microgrid is going to be connected to the grid always. So the grid is going to provide power and, of course, stability and probably other electrical features. And this is the typical functionality that you are going to maintain. Second one is when you have the capability to be disconnected to the grid. So in some occasions, the occasions that normally are because of the price of the energy, or perhaps it's something that is happening by accident because there is an outage in the grid. But you have the capability to work islanded. There are new issues that happen when you have to work in this situation, because remember that the grid is providing you power and also stability. When you don't have the grid, you have to take care of the stability by yourself. This is something that you have to handle in this mode. And finally, the third one is not very normal, but in some occasions you are totally disconnected to the grid always. And this is something that you have to manage in the solution that you have to consider. The appropriate management of generating resources and loads will allow you to fulfill several objectives. These are the three main objectives that you are going to consider when using a microgrid. First one is the savings, using the most profitable source of energy in each moment and avoiding other costs of penalties and getting revenues from energy markets. Second one is sustainability. You are going to use a cleaner energy to power the loads, and it's a clear advantage today. And the third one is reliability, because you are going to be able to operate even with the utility in an outage state or condition. Or perhaps you are going to limit the situation where this outage can happen. We can see here a more detailed description of what a microgrid is. As you can see, it's a combination of solutions that are installed on premises and in the cloud. In the site of each level, we have the responsibility of the connection to the primary distribution equipment and the implementation of the power management functionalities, including protection, the coordination of the protection, the responsibility of the stability when you are not connected to the grid, and also the real-time information, so you will receive alerts and you will be able to operate a microgrid in order to change the state of the different devices according to the preferable operational state. And you have also the cloud level, in which it is installed the responsibility of the energy and asset management, which is including the optimization of the power source usage, so which energy type is used in each moment, and also one very important model, which is the energy forecasting. You need a forecast of the needs of energy in order to perform the optimization. This is a very, very important model. And then at this level, at cloud level, you will also find the enterprise level of integration with another electrical players and markets that are also very interesting for the optimization of the cost of the energy. Let's talk now regarding cybersecurity. We have let it to the end, but I think it's a very important topic also to consider in any system that you are providing that is IT related. And remember that IT is going to be installed in every place, especially also in the fast charging infrastructure. And it's something that has to be considered very, very seriously. One of the problems is what cybersecurity is. In order not to follow interpretations of what it is, then I think the best approach is to consider the compliance with one standard. Our recommendation is to follow the IEC 64443 standard, which is the one that we recommend the use, because this standard is covering all the aspects that are relevant when considering industrial solutions. Please consider the product and system approach, so every brick, every component that you are including in your solution, and how this solution is connected to each other, using probably a network or other devices in order to provide the interoperability of the system. This is considered by the standard. What you have to consider in terms of cybersecurity for the product or for the system. Also, but this is not enough. We have to consider also what it is called the plant approach. So how do you manufacture these equipments and all the elements that are considered in your solution? And finally, the product, the system that is manufactured in one plant is not going to be provided as it is. It's normally provided with additional services, such as, for instance, the installation, the commissioning, the maintenance, that has to be in which cybersecurity is also something very, very important. So this is the only way to consider all the different aspects that are behind cybersecurity, but that are much more than the pure product approach, which is the traditional one. So this regulation provides an excellent framework that serves as guidance to create cybersecurity architectures that are probably the most well-known part of the configuration, and end-to-end cybersecurity services during all the system life cycle. Remember that is design, build, operate, and maintain. And finally, let's finish one relevant success history, including all the main components that we have seen in this presentation: fast charging infrastructure and microgrid system. This is the Energy Bus Depot in Montgomery County in Maryland, in US. This is a 6 megawatts facility that provides energy to more than 40 buses using clean energy, with three main objectives that are covered by the solution. First one is the electrification. That is the conversion of the traditional bus fleet into the electrical one, providing electrical energy to the buses in an optimal way, considering the needs of the energy buses according to the scheduling and different options in the energy mix. There are several possibilities to provide energy to the buses, and we have also different ways to provide energy to each of the chargers in the depot. These things are considered by the solution. Resilience against power outages with the possibility of local generation. And finally, sustainability. The ambition is 80% of greenhouse gas reduction in 2027 and the 100% by 2035. I think this is a very good example of what can be provided in the fast charging infrastructure area, including the provision of a microgrid. With this final example, I will finish. This is all from my side. Remember the main concept we have seen in the presentation regarding fast charging station and the different use cases. The different systems around the concept, the load management, the operation management, the energy management, and the asset management. The life cycle that you must cover: the design, build, operate, and maintain. The four incremental stages for the implementation of the progressive fast charging system. And also, remember the concept of microgrid with the different use cases: grid, island level, and off-grid. The three main values around the concept of microgrid: energy cost, sustainability, and reliability of the power supply. And finally, don't forget cybersecurity as a very important brick to be considered. Hope you have now a better understanding of this interesting and critical infrastructure, the potential value that can be added, and why it's so critical for the infrastructure owners. I give the floor back to my colleagues, and thank you very much.
Thank you, Juan Manuel and Pauline, for your presentations today. Now, it's now time for you, our audience, to get involved. So please ask your questions via the chat box. Now, before we get started, I would like to welcome our panelists who will be leading our Q&A today. So please join me in welcoming. We have Andrew Douglas, who is the Global Segment Solution Team Leader at Airports at Schneider Electric. We have Cara Jordan, Strategic Marketing Director, Automotive and Transportation at Schneider Electric. And finally, we have Vinesh Srinivasan, Marketing and Strategy Leader in the Power Systems Division at Schneider Electric. So we'll just have all our panel come together. Thank you to everyone who submitted your questions while registering for today's webinar. So what I might do is actually kick off our Q&A with a couple of those questions. So the first question, I may direct this one at Andrew. Now, Andrew, this question has come through from Dilson, who's coming to us from Asia. And the question is, how can advancements in energy efficient technologies and sustainable infrastructure revolutionize the future of transportation while balancing the growing demand for mobility and minimizing environmental impact? Which is quite a big question. So I'll hand that one over to you.
Thank you, Megan, and thank you, Dilson. It's a good question. And I think first of all, we've got to take a step backwards and take a look at what's going to power our sort of sustainable transportation of the future. We've got electricity, we've got e-fuels, and potentially hydrogen as well. If we take a look a bit closer at that, hydrogen, it's not going to be sustainable unless it's green hydrogen. And at the moment, green hydrogen is mostly going to be sourced from green electricity. So that's electricity from renewable resources. So we can see here that a lot of what is going to power transportation in the future is going to come from electricity, which is from the grid, or potentially some local generation as well. Now, that means our grid also has to go green, and our renewables at the moment are mostly solar and wind, and they only really generate energy when the sun shines and when the wind blows. So we have to take a look at how we're going to utilize that for transportation going forward in the future. And a big part of that is maybe moving away from our traditional approach here of trying to match our supply. So I try to match our supply to meet the demand on the electricity grid and start to move towards a bit of what can we do of modifying demand to meet that supply. Now, of course, on the grid, we're going to have some sort of grid level storage with pumped hydro and probably big batteries, but it's not going to meet everything. It's going to provide some stability. It's going to provide a bit of shifting of that power to when it's needed. But I think we need to do more. And this is where transportation could potentially come in and provide some of those solutions. On the hydrogen front, generating green hydrogen, it makes sense to be generating that when energy is abundant on the grid and cheap. When it comes down to electricity, and this is for EV charging, we can do some intelligent things with that EV charging. So where there is flexibility with the charging infrastructure, where we don't have to do it immediately, like on, say, roadside charging, you want to do it as quickly as possible, but where there's flexibility, we can take a look at doing it intelligently when the power is abundant. And this is through load management systems, as Juan Manuel was mentioning. This may also involve having some local storage that can add that flexibility of when to draw power from the grid or when to draw power from local generation. And this can also involve a local microgrid as well to manage all of that. This is where we can start to get better use of that electrical power when it's available and using it more immediately as well, rather than some of the inefficiency of storage. The local generation will also allow efficiency because there's less energy loss from transmission. So I do actually see transportation providing some of that modification on the demand side going forward. Thank you, Megan.
Excellent. Thanks, Andrew. The next question, I might bring Vinesh into the conversation. So this question's come through from someone who's actually watching from America. The first one is, Vinesh, I should say, what are your thoughts on how to address or account for carbon footprint from battery manufacturing, for example, lithium mining, so that we can get a more accurate carbon footprint picture from electric vehicles?
Oh, thank you, Megan. Great question. So I guess as batteries, we talk about battery and electric vehicles being, a sustainable source when it's actually being utilised. But if we go back to the source of where batteries come from, obviously, and lithium batteries is probably the most common, batteries with technology we use today. It actually comes from the ground. Obviously, we need nickel, we need cobalt, we need magnesium. All right, so and it's a core area that we do need those resources coming from mines. And again, when we're talking about mining, that is bringing in aspects of are we actually being environmentally friendly. So technologies have evolved, right? So, lithium batteries is what we're using today, but we are starting to see lithium iron phosphate batteries, right? Much more lower density and lesser dependence on, materials such as cobalt and nickel. And then if you even look at some countries are now even trialing, for example, sodium ion chemistry, which again is a lower cost and a lower density, right? And we're lesser reliant on raw materials coming from mining. So we're potentially in the process of eliminating that front end, carbon emissions through that mining process. So that's an area that is continuously evolving, and we're going to see more and more technology. And we've just seen, even when electric vehicles started back in the early 2010, in the Australian as well as the global market, the technology has evolved, and even battery lifetime. Started off originally at about 7 years. Now we're up to 10. We're now going up to 15, and there is now technology that will even push it up to about 20 years. So technology is fast evolving. Through that process, we are reducing the emissions during that early production and manufacturing process as well.
Thanks, Vinesh. Kara, I'll bring you into the discussion. We had a question which came through from Hans, who's in Victoria. And the question was, what do we learn from the COVID-19 pandemic that could help reduce our dependence on transportation?
Great question. Seems like COVID-19 keeps coming back up. So I will say, from kind of a personal experience, one thing that many of us experienced is that remote work is feasible, which really reduces the need for daily commuting and even perhaps our dependence on transportation. However, I really think that the pandemic highlighted the importance of our transportation systems. Just when you look at the profound impact it had, some ports, airports, rails worldwide. So it disrupted schedules and all the way to, really a full-on supply chain crisis, with the flow of goods being so significantly disrupted. But while we saw that severe impact, I think the important thing to look at today is now we're seeing this great rebound and seeing these big investments that are coming into transportation to really bolster the resiliency and the reliability to really safeguard us for the future. So, if you could say that there was a silver lining in it, you could, say that it really accelerated this innovation for the sector.
Thanks, Kara. Andrew, I've had a question which has come through, and I can see a few variations or similar to it coming through live. There was a question around what are the future transportations which give us the maximum in efficiency and sustainability?
Okay, thanks,
Everyone's
Megan.
always interested in what's going to happen in the future.
Absolutely. Another very good question. And so for maximum efficiency, if we're talking maximum energy efficiency as opposed to time efficiency and sustainability, I really don't think you can go past mass transit. We're talking trains, buses, even ferries, really. If you take a look at the statistics, when you're taking a look at a passenger kilometre and the amount of energy required, or even the amount of CO2 emissions per passenger kilometre, mass transit still sort of wins out as being the most energy efficient form of transportation. And the beauty here is a lot of them can be made to be more sustainable as well. Our train networks are already on electricity. If they're sourcing green electricity, that's pretty much solved. Buses in Australia at the moment, there's a transition to electric buses, and in some cases hydrogen buses are also being trialled. So so long as mass transit has good patronage, where you've got good capacity utilization, it's going to be the most sustainable going forward. Of course, if you've got empty trains and empty buses, that's going to defeat the purpose there. When it comes down to that last mile, or where it comes down to regional areas or parts where you're not going to really have the number of people for mass transit, electric vehicles are probably the next bet as being the most efficient and most sustainable. It's going to see people from the station to their final destination, or it's going to be, powering the trucks that go across Australia.
Excellent. Thanks for that, Andrew. Dinesh, there was a live question which came through from Shah. So hello to Shah, who's watching today. His question was on charging infrastructure, which has been suggested. How cost effective is the solution when it's compared to standard electrical infrastructure? Also, what will be the recycling process involved?
Great question. So if we look at the infrastructure as it is today, there is quite a bit of electrical infrastructure we have in place today, and it's great because it's an AC network that we're actually using today, and the current electrical infrastructure is quite suitable. If we do want to still charge an electric vehicle as an example, but it is going to take much slower, and you all understand we're a fast-paced environment, and time is of essence. And at the same time, we want to make sure we look after the environment, etc. as well. And that's where potentially, coming back to your point, is around having purpose-built infrastructure is required. So there is a complexity required for the infrastructure because we do now need special metering, we need special protection, and you will need higher capacity, and sometimes it may need an extra substation. And connection to the grid, and sometimes it's not always available from the grid as well. So, is there another source of energy that we can rely on? These are some of the trade-offs. And to make it even to a next level, as you might be aware, last week the AS4777 was actually updated, which allowed for bidirectional power to flow on the grid. So you can now take an electric vehicle and you can actually trade your electricity on the FCAS market back onto the grid. And that provides another dimension and brings a bit of a complexity onto the actual infrastructure that's required. So typically you are seeing the infrastructure that is required. It is required another 20-25% electrical infrastructure in terms of the CapEx cost and potentially ongoing maintenance as well to have that reliability. Now, it's also important to take into consideration the total life cycle, both of the infrastructure as well as the electric vehicle as well, and that actually plays a role in the selection of the technology that's required. Now, coming back to your second question, which is an interesting portion, is around recycling. So recycling and end of life disposal is a key aspect. Unfortunately, there isn't a standard that is in place today. It's being talked about even for batteries, right? So even for batteries, end of life, what do we do at after 10 years? We have batteries that have been in the market since 2010, when the first electric vehicles were introduced into the Australian market, and we can't just take them to the tip and actually dispose them, right? So there is a safe disposal process that's required. Now, today, there is a little bit of a challenge. In the country today, we have limitation on the ability to actually reuse. A lot of those batteries do need to be exported back out of the country, and you can actually take out about 90% of that content out from the batteries, and it can be reused for other material. Not necessarily batteries, but sometimes can be turned into new cells. Sometimes it can be used for other materials such as chipsets, etc., that can be used for electronics, where we're actually seeing the use of the technology.
Interesting. Thanks for that.
And I'll just add on to that just a little bit on the recycling piece. So yes, there is, we kind of look at this big swell of batteries that are going to be coming into end of life in the next 10 years, but also the opportunity right now as there is a lot of scrap within the battery production facilities. So that's one of the things where we're really looking at how can we help the sustainability of a lot of these battery manufacturing sites in order to reduce their scrap and be able to kind of change the methodology with which they go to recycling. So I know that that's, again, talking about kind of some of these regionalization issues as well, because there is a lot of shipping back and forth that we're seeing a lot of supply chain localization on that. So that is a big piece of the, I would say, overarching story when we look at just kind of the electric mobility with batteries and how the recycling market is going to evolve. I think is going to play a large role in the market in the coming years.
Excellent. Thank you. Thanks so much for that, Cara. Vinesh, I have another question which has come through live. Do we have an indication of what the impact of variations in the source will be on the reliability and availability of the power asset?
Yeah, a very interesting question, because, if we compare it to traditional vehicles, we used to go in and we used to fill in diesel or unleaded fuel and we're up and going. It's a source of power that is available and ready to go. But when we talk about electric vehicles, as an example, the requirement for power is actually fluctuating. So you'll be coming in, you'll be charging for 15 minutes, and then it's just going to be half an hour, maybe empty. The charging spot will be empty, and there'll be no one charging at that point in time. So the demand and supply of power does need to be adjusted. And it's an interesting dilemma at the moment because there is so much power that is available on the grid today. And we see it even with the solar penetration on the grid. We have sort of seen, you might have heard the term, the duck curve. So during the day, you've got an increased amount of solar, from rooftop solar around the properties, which is actually supplying about 50% of the power onto the grid for the Australian market today. Now, off that rooftop, solar, that is during the day. So it's typically you're talking about 9 a.m. to up to about 4 p.m. And after that, you lose, we're relying on other power sources or backup power sources. So the reliability of power and the availability of power does change depending. And that's where we do need to have active power management that is required. So this is one of the things the utilities are now looking at. The power supply utilities are looking at how do we actually manage, because we have DERs and variable EV loads now on the grid. How do we actually manage the flow of power, and when it's actually required in demand to actually supply that power? So that's a key element. And in addition to that, as a consumer, who is connecting to an electric vehicle charger, now you have the ability, also, as I mentioned just before, to actually trade back onto the grid when there is a need, and you've got excess power on your vehicle. So that's a dimension that's coming through. So it is becoming more of a software and analytics that is driving. So there is AI. It'll be interesting to hear that there is AI in the background actually supporting, some managing this power variation on the grid. And it is an ongoing challenge, but it's an interesting one that we do have some technologies now available.
Amazing. Thank you for that. Andrew, I've got a question for you, and it's come through from Rosian, who is based in Asia watching us. The question was, what is the standard protocols used in automation systems for the transportation industry?
Okay, thanks, Megan, and thanks, Rosian. Standard protocols. So taking a look at the transportation infrastructure that we deal with, we do have a standard protocol for EV charging. So it's called OCPP, or Open Charge Point Protocol. It's become the standard across the industry, and it allows interoperability between that and other systems. So it's a good standard to take a look at. When you step behind the EV chargers, if you take a look at the rest of the infrastructure involved in transportation infrastructure, generally they follow the normal industrial standards. So it's not a special transportation standard for the infrastructure. So if you take a look at, say, electrical distribution, for example, then communication is what you'd normally find in electrical distribution. So it's going to be things like Modbus, OPC, DMP3, and IEC 61850. And again, for other infrastructure as well, it generally follows the industry standards.
Thanks, Andrew. Dinesh, I have another question for you. Sorry about that. I feel like I've got quite a few questions coming through for you. The next one is from Freddie, who's watching live. So hello to Freddie. Which is more cost effective, the use of EV or hydrogen-powered vehicles?
Great challenging question in today's environment, Freddie. So like your thinking. So yes, there is a race at the moment between obviously hydrogen and electric vehicles. But it's interesting to observe, obviously, the hydrogen race is a little slower at the moment than we anticipated in the Australian market. Electric vehicles is potentially growing at roughly about 15% per annum. But it is probably, again, it is also slower than what I would say if we compare to other countries, take Europe or China, who are actually, at a fast-paced environment in their transition to electric vehicles. But, coming back to answering your question, it's often driven by infrastructure that's available. So, electric vehicle has been a little bit slow in Australia because the infrastructure, we've got limited infrastructure available in terms of charging and fast charging points. And obviously there are, regulations coming in to support, and we're expecting some government policies to come in as well that will be implemented over coming years that will encourage people to transition to electric vehicles. And hopefully we'll catch up to the likes of the China market in about 10 years. But coming back to specifically answering your question, whether it's, is it more efficient to actually adopt an electric or a hydrogen vehicle? It kind of comes back to two scenarios. So we have seen electric vehicles is quite efficient when you actually electrify, and the losses are much lower from a DC to DC conversion perspective as well, from a technical perspective, and also from a cost of ownership perspective as well. So the capex cost for a electric vehicle is much lower than a hydrogen vehicle, right, today as well, and the ongoing maintenance associated over the useful lifetime. And then the other aspect to think about is also the hydrogen. Hydrogen vehicles, unfortunately, when you have hydrogen in a vehicle, it becomes quite a heavy vehicle, right? So the weight associated is much greater than a battery. Okay? As a result, it does affect the performance and reliability. Where if you look at, heavy vehicles, like so if I take trucks or buses as an example, batteries do become much heavier because of the power that's required. And that's where hydrogen becomes more attractive. So that's why we're seeing in mining fleets and even buses around Australia, there are several trial programs now in place where we're actually using hydrogen as a fuel. So I would say in the low end, consumer, day-to-day family vehicles, electric vehicles seems to be dominating that market as a more efficient choice. But more on the high end, large trucks, buses, we're seeing hydrogen to be a more effective model. But again, evolving technology, so things will change as we move ahead.
Dinesh, while I have you, I'll ask the next question. It was around, and I think it's quite an interesting question. It's come through from a viewer in America. I've often wondered about new or the different workforce that we will need to prepare in the next 1 to 2 decades to support the EVs. Their example was, the current auto mechanics, repair shops will need to reinvent themselves for electric vehicles. Do you, and I suppose open to the panel, does it, your thoughts on this? So, the workforce of the future.
I like your thinking there. Thanks, Megan. I like the thinking from the person who asked the question, so it's an interesting question. Firstly, I guess, yes, there is a change. As humans, we are people who are reluctant to change, right? So we want to be along a journey to actually understand the change and it's a gradual transition. Now, how did that transition actually apply? So we see one of the key aspects is when we actually see industries coming together and making us comfortable. So one is partnerships. So we are seeing the success of transition to electric vehicle applications is going to be partnerships. So it's competitors now coming together. So we have several competitors now coming and forming together, creating standards and making it easier and also providing industry sessions and learning sessions for many people to be upskilled and understand. And if I break that down into a further layer, into more specific people and roles, you take an organisation. Right? I take an organisation like a bus company. Right? As a bus company, they are going to be procuring new buses. So that procurement team needs to be upskilled. They're no longer buying a diesel bus or an unleaded bus, for example. They're now buying an electric bus. Okay. Now, when you when you're actually buying an electric bus, and you now need to understand the electricity market. Right? So the electricity market is much more volatile. You've got the peaks and troughs, and at times when you've got negative prices, when you got 3-5 times the wholesale market prices, and that's actually bringing an interesting dimension. Now, to complement that, obviously, when we are connecting to electricity, you now need electrical infrastructure. So in that bus example, you will need a high voltage power station. So it's understanding, do we have that infrastructure? Who's going to maintain that infrastructure? How do I connect and maintain that infrastructure? So that's one element. Now, if I talk about, as you mentioned in the question around, mechanics and people who actually service and maintain these vehicles, how do they actually become upskilled? So now, from that perspective, we have TAFEs and institutions around Australia now onboarding, future technicians and, upskilling mechanics, which are actually co-funded by the government. So the government's actually providing, programs to actually assist, and with alliance with industry partners like Schneider and in the car industry like Toyota, for example, to actually educate people and take them along the journey and understand the different steps throughout the life cycle and actually how to maintain and operate electric vehicles.
Excellent. Thanks, Vinesh. It is all about the different sectors working together, isn't it? Andrew, I've got a question for you. We are coming close to the end, everyone. But Andrew, I've just seen a question come through from Peter Curley. Rail transport is 7 times more efficient than rubber on bitumen and easier to electrify. Why is Australia not investing more in this?
That's a good question, and I suppose I know growing up, there's a lot of people I know that were rail buffs. So a lot of people like rail, a lot of people use rail, and we always ask the question, why do we have so little in Australia compared to, say, Europe, where rail is prolific, and especially intercity rail. Australia has looked at, there's been many studies done to do intercity rail, put more rail into our cities, into our metros, and the biggest factor holding us back is the economics of it. It's a commercial reality. It's very expensive to build. If you even take a look at Sydney Metro that has been installed, it comes with a very big price tag. It takes a lot of engineering effort. It ties up a lot of the workforce. And we're also seeing in the cities that we have to put it all underground. That adds to the expense. So it is the big capital cost up front that is probably holding us back. And that's what we've seen with a lot of the fast rail studies that have been done, either from here up to Newcastle or to Canberra. The feasibility studies are always showing that it's never going to pay itself. And I think that's sort of turned the government off from really putting that massive investment in place, put it in. So even though it can be part of a sustainable future and it is more efficient, it's just that big capital cost up front that we're going to have to take a look at. The other big thing about Australia as well is we've got these big capital cities that are a long way away, and they're well serviced by air at the moment. it's just we've just got only a few cities, and we've just got to fly the planes between them, and that seems to be an economical way of doing it, compared to say Europe, where you've got a lot more cities that are closer together and a larger population.
Thanks, Andrew. I can see another question which has come through from a staffer who's watching. And his question was, would it be more feasible to individually electrify diesel trains or to extend overhead lines with strategically placed large storage sheds along the route for continuous power supply? Maybe Andrew, if you wanted to comment upon that one.
Okay. Again, it comes down to doing a feasibility study against both, because it's going to depend on the actual situation, the distance. If it's two close cities that you're going to build the line between, you might find that it's more economical to electrify that, especially if there's going to be a large number of services. But as you start to reduce the number of services and increase that distance, it becomes more and more feasible to maybe electrify the train or to have it hydrogen powered. So to take a look at maybe not running the electric lines, electrifying the line, but electrifying the actual locomotive itself. In Australia, that latter tends to be the case. We use rail particularly for freight over long distances, or for hauling a lot of our primary produce, coal and iron ore, etc., etc. Or there's grain trains as well out there for our primary produce. And those kind of long distance tracks with not a large number of services, it's going to lead towards electrifying the train.
Thanks, Andrew. Look, I think we've come to the end of our session today. So I have one more question that I'm going to ask to the panel. And that question is, what do you see are the key innovations and strategies discussed in the seminar that will drive efficiency and sustainability in the future transportation system? So if you can answer that question and maybe any final comments that you would like to make. I might start with you, Cara.
Sure. I will just say overall from the presentation first by Pauline and Juan Manuel and all of the questions coming through, everyone can see there is a lot going on in the market. But we try and kind of simplify it at Schneider Electric to really look at the innovations into three main categories. And we addressed this in the presentation before, but first is electrification. So, utilizing greener power to ensure uptime and the continuity of operations. The second is digitization. So creating this smart infrastructure using IoT and data analytics to really optimize management and improve energy efficiency. And third, I would say lastly, but not lastly for Schneider, is decarbonization. So sustainability is really at the heart of everything we do at Schneider. And there are so many potential tools in the toolbox to help you across all different emission scopes. So you have from microgrid deployments, we talked about the Montgomery bus depot in the US, to renewable energy procurement, and then the I would say most largest piece of scope to tackle, but sometimes the hardest is engaging your supply chain. So for that scope 3 emissions. So there is a lot that can be done on the decarbonization angle. So while we have it simplified into those 3 buckets, there's a lot that comes on from there. So it's a really exciting time for the evolution in transportation.
Thanks, Cara. Andrew, your final comments.
I think Cara has summed it up pretty well. And I think one key thing as well is when we talk about key innovations and strategies in transportation, it is a very, very large topic. And we've only got a short period of time here to cover it all. So focusing on those key areas, as mentioned, with EV charging infrastructure, microgrids, taking a look at the different fuels available for transportation. I think Cara summed it up all very well.
Excellent. And Banesh, your final comments?
Yeah, I think my colleagues spoke about key aspects, but I'll kind of just reiterate. Obviously, we touched on microgrids, a key area that can help us be much more efficient because we are now using DC to DC type of application, especially in electric vehicles and transportation. Increases efficiency. The other aspect we spoke about as well is to obviously the electrification. As we can electrify more and more, we're actually becoming more and more sustainable. And then from a sustainability, it's also important to look at the total life cycle. Right? So waste management, there was a lot of questions around waste management, end-of-life recovery. So it's important to look at end-to-end and also looking also at the behavior. So we spoke about people and behavior as well. So even, what is the time we should be taking transport, managing that congestion in the infrastructure, reducing single occupant travel. So these are the things that we can all do a part to actually make a difference to the environment, transportation.
Awesome. Thank you so much. Well, that's all the time that we have for today. So please join me in once again thanking Kara, Andrew and Vinesh for their time in today's Q&A. And I'd also like to thank our presenters, Pauline and Juan Manuel. I would also like to thank Engineers Australia's industry partner, Schneider Electric, for their support. Now, my next question is, if you don't mind, to please complete the short feedback form, which is linked in the description box below. By completing that, it really does help us to improve and plan our future sessions for you all. So once again, thank you again for joining us today, and we hope to see you at our next Thought Leaders event. Good afternoon.